Hi everyone, welcome to Infinity. Today we have a quick lesson which is exponent, the rules of exponents and so on, and many examples that may be comprehensive. So let's start with the definition of exponent. It's how many times to multiply a number by itself. For example, if we have 3 to the power of 4, if you see this sign, immediately imagine that this number would multiply 4 times by itself. For example, 3 times 3 times 3 times 3, which is 21, which is 81. Another example, 4 to the 4 squared, 4 to the power of 2, 4 times 4, which is 16, easy. This example, which is 2 cubed, 2 cubed is 2 times 2 times 2, which is 8. So let's dive in with the exponents rules. It's actually 6 rules, but it's so easy. You can just after this lesson, I promise you to be able to deal with exponents in general. So let's start with the first one, which is multiply rules. It says that if two numbers, two same numbers with different exponents, and between these numbers a multiply sign, the exponents would be added. For example, 2 to the power of 2 cubed, which is 2 to the power of 3, times 2 to the power of 4. You should add, or you should sum the two exponents here. If the two numbers are the same, so it would be 2 to the 3 plus 4, which is 2 to the 7, 2 to the power of 7, which is 128. And the second rule is the division rule, which is a to the m over a to the n. Actually, that's the opposite of the first one. Now you have to subtract the first exponent to the other. So for example, 5 to the power of 6 over 5 to the power 5 squared, so it would be 5 to the 6 minus 2, which is 5 to the 4, and the final result would be 625. So the third one is when you have like this sign, two brackets with the number to the actually indefinite power, and the in the outside the brackets there is a sign or the exponents. So the rules is to multiply n by m, the two numbers. For example, 3 squared to the 4, you have to multiply both exponents. 3 to the power of 2 times 4, which is equal 3 to the 8th power, which is 6561. The fourth one is when you have exponents and multiplication operation here to the power. You should subtract the power to the both to the both numbers. For example, 2 the exponent 2 times 5 to the 3, you should distribute 3 to 2 and to 5. So it would be 2 to the 3 to the power of 3 times 5 to the power of 3 equals 2 to the power of 3 is 8, and 5 to the power of 3 is 125. It would be 1000. So the two last rules, so it's so easy actually. If you have a number to the negative power, you immediately would flip the numerator to the denominator. For example, 2 to the negative 3, you should add 1 in the denominator over this number actually. So for example, another example, let's take 3 to the negative 2, 2 to the negative 3 to the negative 2. So if you see this negative sign, you should flip and write 1 over this without the negative sign, 3 to the 2. Okay. Okay, last rule is wherever the number is raised by 0, the result would be 1, even if a million over a million to the power of 0 would be 1. So let's go to some practice equations. Pause the video and try to solve these equations on your own. Pause the video and try to solve it on your own. Solve all of them on your own. Okay, let's follow the rules here. The first one is 2 to the 2 squared to the 3, which says like this rule. So first exponent would be multiplied by the outsider or the external exponent. So it would be 2 to the 2 times 3, which is 2 to the 3 is 2, 6. Okay, 6. Okay, here 100 to the power of 0 says every number raised by 0 is 0, so it's 0. Sorry, it's 1. Sorry, 1. Every number raised by 1, it's 1. Every number raised by 0 is 1. So another equation, 5 to the negative 2, we see negative, so 1 over this number, 5 over 2. And the last one is 3 squared times 3 cubed. We see same numbers with different exponents and the multiplication sign between them, so we should write the same number and sum both exponents, which is 3 to the 5, and we are done. Thank you very much.